we're going to finish up 8-5 today. This is 8-5, day 4. Okay, I'm going to set up a few problems with you just because they're a little bit different. This first one is your number 19. So you'll be finishing these for homework. So there's no examples that I'm going to do. These are going to be your homework problems. I'm going to set them up and then let you finish them. And then I've got a couple of problems on a worksheet that are review problems. But the first one you're going to have is number 19. What you're going to take is the region under the graph of y equals x to the point 6 from x equals 0 to 4. And we're only going to rotate that a quarter turn around the x-axis. So rotate a quarter turn around the x-axis. And I think they're rotating. Forms the backside cross sections. Well, they show you a picture here. Well, I'll show it to you in a second. X raised to the point 6 kind of looks like this, stopping at 4. And then they show it to you. I'll put it under here real quick so you can see where we're headed. Right here. So they're kind of making it, but it's straight here for some reason. I don't really know, unless they're just reflecting it. But the sections are not cylinders or washers. They're these triangular prisms is what they are. That shape there. So what we're going to do is use the formula for the volume of a triangular prism and integrate that, because that's what's going to happen all the way through here. They just keep growing as they go out. And when we integrate, it keeps finding all those areas. So our formula is not going to be a washer or a cylinder, but the area for the volume of a triangular prism. And this are the same equation. Because I think it's rotated, but rotated to make it round. I don't really know what's going on here. You can read that to see, but that's what we're working on. So the bottom part of it, it's the same graph. You get this to this to this. Well, maybe that is rounded, but when you take them small, it gets that straight look. So anyway, because we're going to start with our rectangle perpendicular to our x-axis. And again, when we rotate, we're going to get this triangular prism shape. Okay, I need my boundaries on the x-axis, so that's 0 to 4. They gave me those. And the volume for a triangular prism is 1/2. It's the area of the base. This base is a triangle. Yeah, the volume of any prism is the area of the base times by the height. And our height is that dx, it's that width. So it's just the area of the base, and the base is a triangle. And the area of a triangle is 1/2 base times height of the triangle. And then the height of the prism is our dx. 1/2. This base distance is given by this equation, y equals x to the point 6. This height distance is the same equation, y equals x to the point 6. And there you go. This is called plane slicing. You slice planes in there and you find the volumes of the smaller shapes that you get. All right, there's 19. 22. So you can leave room to set that or finish that one up. 22, what do we have going on here? A wedge. Find a formula for the volume of a wedge of altitude h cut to the central at, oh no, I'm reading the wrong one. I was going to say volume of a cone. Prove the volume of a right circular cone of base r and and altitude h is given by, so we're looking at the volume of a cone that you used in geometry. So the formulas we were using in geometry were actually created in calculus. So if the radius is r and the height is h, we know that the volume is 1/3 pi r squared h. Calculus came up with this formula, and the way it came up with it is you think about the line, this line here, revolving around the y-axis. So what I know about this line is the point is up h units and the base is out r units. So if I take this region and rotate it around the y-axis, it will create this cone here. So what we need is the equation for this line, because that's what's going to give us the height of our rectangles. So the equation, we're going to use the ordered pairs here. This ordered pair is over r, 0. This one is 0 and up h. So if I use the 2 points, I can now write the equation of this line. So to find the equation of a line, I need the slope. Slope is rise over run. I'm going to rise h units. So I'm going to do slope, rise h, run in a negative direction r units. So negative h over r is the slope. The y-intercept is crossing at h. So the equation for that line is y equals my slope plus the y-intercept. So now you need to write the volume of this region, which is going to be the cylinder formula, pi r squared h, as that rectangle rotates around. So volume equals, and this is where I want you to finish it up. You need y boundaries, pi, you need the radius, which is determined by this equation, but you're going to need the equation in terms of y instead of x, and then a dy on the end. So I'll let you finish that one up. (23) is the next one. A sphere. We've got a sphere of radius 10. Find the volume of the sphere by calculus, not your geometry formula. So if you think about it, a sphere is created by taking a quarter, or actually a half a circle, and rotating it around either the x or the y-axis. It doesn't matter. So you could do this one any way you want. I'm going to go around the x-axis. So if I take this half circle, radius is 10, and I rotate that around the x-axis, I'm going to get a sphere. So if I find the volume of this bounded region rotated around the x-axis, I will have the volume of a sphere of radius 10. Okay, the thing you have to remember is, what's this equation here? They didn't give it to you. You have to know that that was a circle, and the formula for the area of a circle centered at the origin is x squared plus y squared equals the radius squared. So you're going to have to rearrange that to get it in the form you need. Your boundaries are here, and then do your, and this, because the rectangle is touching the axis, we've got a cylinder again. Okay, and then the last one from the book is 24, and it's a lot like this one. It's just going to be the general case. Here we did it specifically for a radius of 10. Now you're going to come up with the formula. So your final answer when you're done with 24 should be 4/3 pi r squared h. This is what you should end up with. Because what they want us to do is take that same circular region but this time just of radius r. Oh, what the heck, I wrote down the wrong thing. 4/3 pi r cubed. There's no height on a, that's r cubed. Sorry. Okay, so our equation here, x squared plus y squared equals r squared. So you're going to be carrying the r through the problem here. And set up your volume just like you did on 23. Work it through, and you'll have r's left in your problem, and it should be 4/3 pi r cubed. Okay, so you have those four, plus I'm going to give you a worksheet, and it's going to be problems 13 and 15. Actually, 13 parts C and D, and then 15 has two parts A and B. Okay, that's going to be it there.